Hey Kipsters, today we are going to be working on Module 4, Lesson 5, Graphs of Functions and Equations. Take a few seconds to make sure your paper looks like mine, and let's get started. Our objectives for today are that we're going to be able to define the graph of a numerical function to be set as all points, x and y, so as an ordered pair, with an input of x of the function and a matching y output. We are also going to tackle matching numerical functions with their graphs. All right, let's look at exercise number 1. I'm going to zoom in a bit. Remember to set up your proportion as your first step to begin creating this two-variable equation. I'll even help you out. One side of your proportion should have y over x. What does this equation in two variables look like? Well, when I set up my left side of my equation, y over x equal 2, I know on my right side I need my distance over my time. So I'm going to substitute in this 3 that I annotated for my distance over this 21 that I annotated my t of my time. I know that my next step in creating this two-variable equation is to cross multiply. So I'm going to have 21y equal to x times 3, which is 3x. We want to isolate which variable? We want to isolate the variable y. So I'm going to divide both sides by the number, the coefficient attached to y. All right, so I'm going to see 21 divided by 21 canceling out. And I'm left with y equals 3 over 21x. Alright, so most of us are tempted to say that we can stop here and that this is our equation. What do you notice about the numbers 3 and the numbers 21? Yeah, 3 and 21 have a common factor. That common factor is actually 3. So when I take my numerator and my denominator and I reduce them both by 3, I get a new fraction, y equals 1 over 7x. Box that out. Thank the Lord, thank the Lord. All right, let's go to the next exercise. Use the equation you wrote in part A. So my numbering got off. All right, so this is part A. Use the equation you wrote in part A to determine how many miles Giselle can run in 14 minutes. Okay, so we want to know the distance she can run in this amount of time. So step 1 is to write the equation that I've been given to work with. I know that step 2 is always to substitute in the variable I'm solving for. Based on the information given and what I've annotated, which variable am I solving for? I'm sorry, I said that wrong. Hand. That's how I tell myself to cut it. I want to determine which term I'm going to substitute into the problem. Would I be substituting my variable x or my variable y? Yeah, I'm going to be substituting my variable x because I am solving for my distance. So when I write using substitution instead of an x, I'm going to input a 14. I'm going to be replacing my x with that 14. Alright, so I know that I can multiply whole numbers and fractions by making my whole number a fraction. So I'm going to put 1 under my 14. I'm going to multiply straight across. 14 times 1 is 14, and 7 times 1 is 7. I'm not done because I see an improper fraction that could be reduced. So I know that y is actually equal to what? Y equals 2. But let's answer the question. How many miles can Giselle run in 14 minutes? Giselle can run 2 miles. Great, let's move on. Our next question. So for a given input of x of the function, a time, the matching output y is the distance. So for any given time, there should be a matching distance. Giselle ran in that time. Write the inputs from the work that we just did as ordered pairs and plot them on the chorded plane. What does the work from parts B through D look like as ordered pairs? Yeah, you should have 14 and 2. You should have 28 and 4. And you should have 7 and 1. Remember, it's not about which number is bigger. It's about which number represented our distance and which number represented our time. And when I go back to the first problem or the second problem where I started to do some calculation, I see that my time was 28 minutes. So I want to make sure that in my ordered pair setup that my time is set up for my x. What would a graph of this equation look like? Go ahead and make sure your graph looks like mine. I'll zoom in on the points that matter. What do you notice about the points that you plotted? What do you notice about those points that you plotted? Yeah, you should notice that they appear to make a line. They appear to be in a line. Is this function discrete or not discrete? This function is not discrete because we can find the distance Giselle runs for any given amount of time. Remember from yesterday's lesson, time is one of the time is one of the inputs that normally tells us that this is a not discrete function because we can have half a second or we can have half a minute. All right, let's use the equation we wrote in part B to determine how many miles, so we're still calculating some distance, Giselle can run in 36 minutes. Let's write our answer as an ordered pair when we're finishing. So now that we have this ordered pair, let's graph this point on our line. So I'm moving up to the top of my paper, so I'm going to go to an x of 36, and I'm going to go to a y of 5 and 1/7. Okay, 1/7 is smaller than a half, so I shouldn't be halfway in between my 5 and my 6. All right, then let's answer this question. Is this point where you expected it to be? In other words, is this point in line with the other points, or is it off somewhere by itself? Yeah, you should tell me that this point is where you expected it to be, not off by itself. Let's go to the next part. Assume you use the rule that describes the function to determine how many miles Giselle can run for any given time and wrote each answer as an ordered pair. Where do you think these points would appear on the graph? Yeah, you should tell me that all of these points should appear on the line. All right, what do you think the graph of all of the inputs and all of the output pairs would look like? Explain. Hopefully you said that the graph of the equation, hopefully you said that the graph of all of the inputs and outputs would be a straight line because we were told Giselle runs at a constant rate. That means each time she runs, it will increase at the same rate. Connect the points you have graphed to make a line. Select a point on the graph that has integer coordinates, so that means whole numbers, that has integer coordinates, and verify that this point has an output that the function was assigned to the input. So I am looking at my graph, and I am going to use my straight edge to connect these points. I'm going to examine my graph, and I see 28 and 4 as a pair of integer coordinates. So I'm going to write my equation as I've been given, knowing that I'm trying to verify 28 and 4. What would my equation look like substituting in my given x and my given y? Compute the math on the left-hand side, and if your left side equals your right side, Because my left side is equal to my right side, I know that these points are on the line. All right, we're going to do number 2 with our partners. Go ahead and track me when you are done.